Welcome back. Today I'd like to speak to you about a very unique function which we can use in process control, and that is going to be known as set point tracking. It's something that you may use or something that you may not use. If you go back to my video on cascade control, you would have seen that there was a reference to set point tracking in that video. Let's discuss this from a practical point of view. What we're going to find is that set point tracking is when a machine copies what something else is doing so that that machine can stay ready all the time. In a very simplistic form, you might be with a friend, and what you decide to do is you decide to imitate everything that your friend is going to go and do. If they were to move their hand up and down, you go and move your hand up and down. As they move it, you're going to follow them. So in this case, you're not trying to reach your own goal. What you're doing is you are tracking what they are doing so that you are ready to act with whatever reason you are going to go and have. Set point tracking is going to have exactly the same idea. From our point of view, the controller is going to watch a process value and it will follow it so that when the real control starts, everything is going to be smooth and there aren't going to be any sudden jumps that we can have in the process itself. And this would work with any type of process that you are dealing with. Maybe we can go and, for example, work with a flow control. I'm going to go and have a valve put in the line, and my flow is going to come in from the left-hand side and it's going to go out to the right-hand side. It's going to put that down as the outlet. And you can go and measure this process of yours. Now, with flow, you can either measure upstream or downstream. Most people prefer to measure upstream because the valve can cause disturbances. It doesn't make a difference. I'm just going to go and put in a flow transmitter and take that to my flow indicator and controller, which will have a set point, and that is now going to go and operate the valve that we have got. So in essence, what we're going to find is that set point tracking, often referred to as PV tracking or process variable tracking, is going to be a control system that features when the controller's internal set point is forced to follow the measured process variable whenever the loop is in the manual mode, or if we're looking at initialization, or if we want to have something like bumpless transfer. Without PV tracking, switching from manual to automatic can cause a sudden jump in a controller output because the controller may have an internal set point far away from the actual process variable of the system. In that case, the jump can shock the process, or we can overshoot our values, or we can trip equipment, or we can go and destabilize a process. Let me go and demonstrate this to you first and foremost. So I've got a process over there, and if I was to run this process, you can see that the process variable, which is the red pen, is going to make its way towards set point, and it's going to keep changing the output until there's no error. And wherever I change the set point, that process variable is going to make its way towards where it has to be. Now, this circuit of mine does not have PV tracking, and let me show you where the disadvantage comes in. Imagine if you're the operator and you put the process in manual and you try and get to a process variable level of your choice. I can take the output and let's go and increase the output by a certain amount, and the process variable moves, and you say, okay, I don't want to be there, I want to be a little bit more, and we go and change that output again. And the operator says, let's just go and adjust it a little bit more. And they go and do that until they get to the point where they're happy. And they say, right, now my process is nice and stable. And now I'm at the position where I can go back to automatic. But be careful. Look at where my process variable is sitting and look at where the set point is. And if the operator forgets that the set point is not at the process variable and they press the auto button, can you see the disturbance that is introduced into the process. And so the whole system is just going to go and take a big knock. Now, if we put in PV tracking, that's not going to happen because the controller is going to start off with no error whatsoever. The PID controller is now going to be subject to a bumpless transfer. We might use this in important sequences, especially with startups. We might use this in cascade loops, as you would have seen with my previous videos that I have gone and put together. You might use these in split range or override systems. The whole idea is that it's going to achieve a smooth transition from manual to automatic. We're not going to have any output spikes. We're not going to have any sudden valve movement. And we're going to have stable loop behavior at all times. And that means that the operator is going to have confidence in the system when they hand over from manual to automatic. You might have a temperature controller that is in the manual mode and the process variable is sitting at 150 degrees Celsius, but the set point is at 120. As soon as the operator goes back into auto without any tracking, the controller is going to see that there is a 30 degrees error and it's going to start to open or close steam valves. Let's go and demonstrate this. I'm going to put the controller into manual and see if I can find where I've got that hidden away. This is it over here. That set point tracking is not switched on, so I'm going to go and switch it on. And that's it. Right. I'm still in manual. You can see that the process variable and the set point are together with each other. I'll change the output, take that up maybe to 25%. Look at how the process variable follows the set point, or how the set point follows the process variable. There's tracking that we have got. Let's go and change that output and maybe take it up to 45%. And once again, you can see the automatic tracking that is happening on the right-hand side, which is there so that the second when I go and put that process back into automatic, we're already at the set point and we're not going to have any bump in our transfer. So this is one of the unique features of a set point tracking, something that I'm going to encourage you to use as often as you can. And that wraps up our short segment on set point tracking. Please do go and use it if it is going to work for you. And as always, you can find a number of different courses that I do present at the bottom of the screen.